Hey everyone, Mr. Skelton here. We are beginning our lesson on Unit 1, Assignment 1, in Honors Algebra 2. We are solving equations. You're going to find in this lesson that a lot of the problems you see are review. You've seen problems like this probably before in Algebra 1, but it's good to kind of at the beginning of the year get the ball rolling a little bit and get your brains going and firing away with some Algebra 2. So when you do some problems today, feel free to hit pause and try them on your own. You may find that you can do some of these on your own, and then you can always go ahead and push play to see if you got the right answer, or if you are unsure about something, you can watch me go through it step by step. So let's jump right into it. We got two learning targets today. One, you can solve various types of equations, including proportions, fractions, and equations with variables on both sides, as well as being able to apply the concept of solving equations through a word problem or application problem. So the setup and solving is what you will have to do towards the end of this lesson. So let's jump right into it. The very first question, you'll notice you have variables on both sides. You also see some parentheses with a number out in front. We're going to be doing some distributing. As you do this problem, you'll find that there are many different ways to go about this in terms of the steps or order you do things. Bottom right hand corner, you'll notice that the answer is provided to you. So if you wanted to go ahead and hit pause at this time and try it on your own, you can. You should get 6 for y when you are finished. That said, I'm going to get started. So I'm going to distribute this 2 just to the 3y and the negative 9. So it's going to give me 6y minus 18. This minus 9 here is not affected by the 2, so I leave it. I distribute the 5 through, so I get 5y minus 15. The minus 2y and plus 6 stay as is. What I'm going to do next is I'm going to combine my like terms on either side of the equal sign. So I have a negative 18 and a negative 9, which is negative 27. And over here, I have negative 2y and positive 5y. Don't add the opposites here because they're on the same side, so that would just be 3y. Negative 15, negative 6 would be negative 9. Now, since I have basically the constant here of negative 27 and negative 9 and 6y and 3 kind of isolated on each side, now I can add opposites or subtract opposites, however you want to think of it. And I get 3y minus 27 equals negative 9. And I can add 27 to both sides and get 3y equals 18. Divide by 3, and I get y equals 6. Okay? Let's move on to the next. So this problem, I know, can be a little challenging for students, especially in the beginning of the year when their brains maybe aren't firing away with math or with algebra. So you'll see here that you have fractions on the left-hand side. One way to do this problem is to get a common denominator for each of these fractions and then go ahead and maybe set up some type of proportion. I wouldn't do that. When you have fractions, for me personally, I always like to clear the fractions and get rid of those fractions within a problem. The way to do that is to focus on whatever the denominators are in the problem, and you want to find the LCM, least common multiple. So if you look at 2, 3, and 6, what is the least common multiple of all those? It's 6. So what we're going to do is multiply the entire equation. Don't forget about the 4 here. We're going to times the entire equation by basically 6. If you want to put 6 over 1, that's fine. So what basically happens is you get 6x over 2 plus 6x over 3 plus 6x over 6 equaling 24. Now, you don't have to write this step out. I just kind of want to show you what's happening. And the reason we can times everything by the LCM and the reason these fractions go away is right here. When you simplify this, you get 3x, you get 2x, you get x, right? 6 divided by 6, 6 divided by 3, 6 divided by 2 equals 24. And now look what you have. You have a nice equation with no fractions. So you add your like terms up, you get 6x equals 24. You divide both sides by 6, and you get x equals 4. Check. Okay? Next we have question number 3, and this is a application problem. Let's just read it through it real quick. We have 2 buses that leave Houston at the same time and travel in opposite directions. One bus travels 10 miles an hour faster than the other. In 4 hours, the 2 buses will be 480 miles apart. How fast is each bus going? Ooh, good question. So you may remember these problems from your Algebra 1 days. We used to call these the dirt problems, right? Distance equals rate times time. For me, for my money, anytime you read a question in a math class, or it could be any other class, could be a different class that could be asking you a question like this, if they're talking about distance or rate, remember rate is speed, essentially, and then time, you can use distance equals rate times time, and we can manipulate that equation and solve for either one of these variables to help us with the problem. All right, so let's kind of go through a little setup here of what we have going on. So essentially we have bus number 1 and we have bus number 2, right? We have 2 buses and they're traveling in opposite directions. So I'm going to kind of put an arrow here and kind of give you a little setup. And I'm going to call this distance 1 and distance 2, right? Because what are they asking us? They're asking us how fast is each bus going. They're traveling in the opposite direction, but basically if I take the 2 distances and add them together, I know I'm going to have 480 miles between them, right? If they started here and bus 1 went west and bus 2 went east, I know that after 4 hours, if I add up their distances, they're going to be 480 miles apart. Okay, so now that I have the distance of bus 1, distance of bus 2, remember here's distance, I want to substitute in for these d's the rate and time of these buses. So essentially, because d equals r times t, I'm going to use substitution and put r times t here, plus the rate and times time of bus 2 equal to 480. So just pure substitution. I can make that d1 if that's helpful, or d2, it's the same thing. Now, it says one bus travels 10 miles an hour faster than the other. So when we try to figure out what r is, or what to put in for r, I'm going to put x. We don't know what the speed is. That's what we're trying to figure out, right? How fast is each bus going? So I'm going to call this x. Well, if one bus is going 10 miles an hour faster, this one has to be x plus 10. Now, someone may ask me, well, could this one be x plus 10 and this one be x? It could. So it doesn't matter where you put the plus 10 on this problem. Now, time. What do we know about time in this problem? It says in 4 hours, the 2 buses will be 480 miles apart. So both of them traveled 4 hours. So for time, it's 4. For time, it's 4. And now we're going to just simplify and solve. 4 times x is 4x. I'm going to distribute this 4 through, so that'll be 4x plus 40 equals 480. And we're going to solve this. So 8x plus 40 equals 480. And I would subtract, so I get 8x equals 440. And divide by 8. And if we do that correctly, I believe we should get 55. Okay? If you don't, you can always take out your trusty calculator, your scientific calculator real quick, 440 divided by 8, and you should get 55. Okay? Now, how fast is each bus going? We found one of the buses. We know in the problem that one bus travels 10 miles an hour faster. So if our 2 variables were x and x plus 10, we know the other bus has to go 10 miles an hour faster, so 65 would be my second answer. All right? Challenging problem. You may or may not recall those from your Algebra 1 days, but a good problem nonetheless. All right, one more problem to go and we'll be done. So here we're solving for W, okay? These can be tough. You see a lot of these, you know, if you have like area equals base times height, right? If you remember from your geometry days, and I said, okay, solve for h. How would we solve for h? In other words, how would we get h by itself? Well, we'd kind of do opposite operations, right? B times h, so we would divide both sides by b, and I'd get a over b equals h, and now I've solved for h. Literal equations is what we used to call them. So here, you have 2 w's, and so what's tricky about this one is a lot of students will look at this and say, well, if I want to solve for w, I have 2 of them. How do I get 1 w out of the 2? Well, I'm going to clear this 7 out of the way, so I'm just going to bounce it to the other side. So I'm going to have AW plus BW equals 22. And then I'm going to factor out a W. So if you remember from your factoring days, if the 2 terms have a like term in it, or in this case the variable, that's the same, we can factor out that W. And it would look something like this. If you went backwards and distributed W back through, you should get what's in red. W times A would be AW. W times B would be BW. So I just factored out this W. Now remember, there's really multiplication in between the W and the A times B, so what I can do to get W by itself now is just divide. And so I should get W equals 22 over A plus B. And that should be my answer, and you can see that off to the right. Okay? So the problems that I did in this lesson, I didn't cover every single problem that you'll see on the assignment, but the concept will stay the same, and that is you are solving equations in a variety of ways. You'll have some literal equations where you're solving for a variable. You may have a application problem like the bus problem. You may have some fraction problems that we did in 2, and you may have some just basic solving with some distribution and combining like terms and so on. So as always in class, as you're working on your assignment, more than willing to help. Hopefully your group members can assist you as well, because I guarantee after being away for quite some time in the summer, it's going to take a little bit of time to get your brain back in school mode. But I look forward to seeing you in class, and I'm more than willing to help you out with anything you need. All right? Take care.